All right, hello everyone. Welcome back to General Chemistry 1. For Chapter 7, the main goal is to be able to draw Lewis structure and predict the molecular geometry of the molecules. Here are the a few steps to determine. First, we need to determine the valence electrons, and each valence electron is represented by a dot. Now, after you got the valence electron, you can follow all this step to figure it out, but there's a easier way to do that. Okay. The after you get the Lewis structure, then the next concept will be the bond polarity, and that should be good enough for Chapter 7. For the molecular geometry, that Chapter 8 will take care of that, and we got a few table here. One is this is probably the most important table, the VSEPR table. When you always start out with the basic geometry, when you treat the surrounding atoms or the lone pair the same way. Now, notice if you have lone pairs on the central atom, then you start moving away from it. Okay, so but your basic geometry is always going to be the first one on the left. If you have two lone pair, you move 2 steps away, and you end up with a different shape, because this is the shape that not taking lone pair into considerations. Okay, the actual shape of the molecules. All right, so let me show you a couple of things. Under whiteboard notes right here, under lecture study guide, you will find all the specific example. For example, VSEPR number 1. There's a new one that I just posted, which is the valence electron. Actually, I want to open that up real quick, okay? Because some of us might wonder, might already forgot how to figure out valence electron. So I make a summary here. Valence electron, they go by group. Group 1, each atom has 1 valence electron. For example, sodium, lithium, most of the time you're going to be dealing with hydrogens, 1 valence electron. Group number 2, 2 valence electron. And here's the example, calcium, magnesium. Group number 3 to 12, that can vary. So, and we're not going to deal with these guys. Like iron can have 2 or 3 valence electron, and so on and so forth. Now, when we get to group 13, things get back to normal. You drop the 10, and you got 3 valence electrons, such as aluminum, gallium, boron, B. I didn't put it in here, B. Group 14, this is very popular. 4 valence electron, that's carbon, silicon. Group 15, you got 5 valence electron, nitrogen, phosphorus, so on and so forth. Okay, so you got a whole comprehensive list right here. Lewis has an amazing way to represent valence electron and bonding stuff. Very logical. Each valence electron is represented by a dot. And that's why Lewis structure is also known as a dot structure. Now, valence electrons are distributed around an atom evenly in sequence. So, if you have 1, doesn't matter where you put it. Top, bottom, left, right, left. You have 2, you can put 1 on the left, 1 on the top. But again, you can change that. You have 3, so you can see it start filling 3 corners. And when you have 4 carbon, that's 4. So this is the maximum single electron you can have. Okay, you don't want to do 2 pairs. You have to spread them out evenly. That's the key. When you get to nitrogens, then you keep a sequence. Let's say here I start out from the top, but you can start out on the left. I go 1, 2, 3, 4, because nitrogen has 5 valence electron right here, group number 5. 15 has 5 valence electron, so it's 5. So after I go 1 round, it's only 4. So the 5th one's gonna fall into one of the pair. One of the electron, make it a pair. So here I make the top one as a pair. Okay, but again, you can do that on the side if you want, the bottom if you want. oxygen, you start out oxygen 6 valence electrons. So you go 1, 2, 3, 4, and then 5, 6. Okay, so you start out 1, 2, 3, 4, and then number 5 will pair it up, and number 6 will pair it up. So you got 2 pair and 2 single, and so on and so forth. You got halogen will be 7 electrons. So you got 3 pair and 1 single. And again, you can put a single on the top, left, right, wherever you want. And finally, xenon, which is the noble gas, it has 8 electrons, make 4 pairs. Okay. Okay, so that's valence electron, and that's very helpful because we need that. Okay, for Lewis structure. Now, if you remember last time, for every single molecules, you have to do all this stuff. I believe we talked about this last time. Okay, but here they are again. So after you make the connections, in chapter 7, you make the connection. You got a C double bond O on each side, and that's your central atoms. And you look up on the table in chapter 8, it shows linear electron geometry and also linear molecular geometry. Remember, when the central atom does not have the lone pair, the molecular geometry and electron geometry are the same. Same answer for item 2 and 3. Item 4, we need what we call electronegativity, and I have a handout for that, okay, in whiteboard notes. So electronegativity, you take the oxygen, you minus the carbon, you got 1.0, and that's make it a polar bond because it's more than 0.4. Now, overall molecule is tricky because you have 1 CO on the left, you got 1 CO on the right, and it turns out they cancel out because, opposite directions, they cancel out, like vectors, okay? So that's why overall there's no polarity or non-polar. And it's a linear straight line, therefore the bond angle is 180. So don't forget that table in chapter 8, okay? So yeah, you can go through all that, and I'm picking one from the bottom here. Sam, CF4, if you got 4, you got a carbon in the center, and 4 fluorine. Electron geometry and molecular geometry are the same because carbon has no lone pair on the carbon, central atom carbon, and that's a tetrahedral. Okay, if you look at the table again, chapter 8 table, VSEPR table. Bond angle, it tells you in there 109 degree. Bond polarity is the difference, so I would take F, which is 4.0, minus 2.5, which is carbon, gives you 1.5. That bond is very polar. Now, overall polarity is non-polar because you have 4 identical fluorine. That's a perfect symmetry. So all the polarity cancel out. Every time you have a good symmetry, they cancel out. Okay. If you have a mismatch, like you have 2 hydrogen and 2 fluorine, this is not a symmetry. It looks like it, but it's not, because we're talking about 3D right here. Okay. So overall polarity is polar. Same for CHF3. The only time you can have a symmetry is when you have 4 identical, 4 the same kind. Okay. So so if you know all that, that should wrap up. Wrap up chapter 8. And then one last thing is the hybridization. I also have that table on chapter 8. The hybridization is when orbitals are mixed together. Hybrid means mixing together. You have sp, that means 2 orbital s and p mixed together. So you got 2. If you have sp2, that's spp, so that's 3 orbital s and p and another p. So so you mix them together to become an sp2, and you got 3 of those. Now sp3 will be 4 because it's spp, so that's 4 orbitals, and then so on and so forth. You have 5, 6, and I've got that table for you on chapter 8. Okay, so if you look at that, so basically you count number of bonds, or remember the lone pair is considered to be like a bond because you need space for the lone pairs. 1 pair of electron is equivalent to a bond. Okay, so from that numbers, It's also known as electron groups. You can tell what the hybridizations. Okay, for example, let me show you guys this. Let me show you guys the lecture study guide right here. Okay, right here. If you have SP right here, the very first one, linear SP, 180 degree. So you have only two bonds. You're looking at beryllium. Beryllium has a one bond on the left, one bond on the right. So that's SP. That's only two orbitals. SP2, that's three because that's SP and P. Okay, so you got three orbitals. So you can tell how many bonds. So you count CH4, that's 4. 1, 2, 3, 4. So you know it has to be SP3. Because SP3 is S and 3P. That's 4, right? And the bond angle is 109. And then D, SP3D, that's 5. That's add another one. 1, 2, 3, 4, 5. And 6 will be SP3D2. And that's how I recognize them. Okay. I think that's it for chapter 7 and chapter 8. So if you know, only one last thing is called MO theory, which is the original theory, and we can get that on the next meeting, and before we move on to the next chapter, which is the gas laws. Okay. All right. So do your practice, do your homework set number 3. There's a lot of good one in there, and work on your lab number 6. All right. Thank you very much, guys, and see you in the next lecture.